Hi, I'm glad you're all here. It's actually going to be my first talk ever, so let's see what this brings. I'm Albert. I'm pretty new to Elixir. In fact, I first used it about a year ago for a class project at university where we had to write a video streaming server. Everything went extremely well until it came to deployment. I just could not figure out a simple, smooth, non-interactive way to build and deploy that thing from a CI server. In the end, I just gave up and rewrote the thing in JavaScript in an afternoon and decided to dedicate the next year of my life and my bachelor's thesis to try to figure out how to deploy Elixir. So here's what we're going to cover in the next 40 minutes. First, we're going to look at the basic mechanism whereby the beam swaps your modules. It's actually really simple. And we're going to inspect OTP releases. Next, we're going to look at sort of the core of the upgrade process, the upgrade instructions that you find in your relup files. Then we're going to look at ways to ship your release from wherever you built it to your servers and start it there. Now, then we're going to talk about some of the things that can go wrong and how you might deal with that. And lastly, we're going to look at ways to automate the whole process and see what's out there. So let's start. Now, before we actually get hot swapping, I want to just say that if you can avoid doing hot swaps in production, then please do that. There's really just a lot of added complexity that if you can avoid, you should do so. Unless you're absolutely certain that you really need hot upgrades, please just pack your release or just start a server like this. So sort of valid reasons to use hot upgrades would be if you have a lot of long-lived connections that you cannot easily drain, or that if you would just cut them out, they would cause like a reconnect storm and bring down your machine once more. Or if you've got a lot of in-memory state, like for example, if you're building a game server. So if you can't do rolling restarts, please do, but then again, we're here for the hot swap. So let's look at the mechanics. So basically, hot swapping is done on a module level. What that means, so the beam can keep up to 2 versions of one module loaded in memory at once. Say we've got this module loaded, and from it we have spawned a plain old process. It's no gen server or anything, just something that runs a tail recursive function. Now, say you change something in your file, save it, compile it, load it. What's going to happen is the file that you just changed is going to be loaded, and it's going to be marked as current, whereas the old version that's been running previously is now marked as old. Note that your process is still running the old version of the module. And just to keep things interesting, let's also say our process gets some internal state and that we've changed the representation of that state in our upgrade. So what we want is a way to transform that state so that our new code can just deal with the new state. And the way you do this is you ship, as part of your new release, an upgrade or a state transformation function. It'll receive the old state, transform it somehow, and then just continue the tail recursive loop just in the new module this time. So to actually switch over execution, what you need to do is to make a, what's it called, a fully qualified call. So that's your module name dot function name. And in this case, we do that by sending our process a message. That could be anything. We'd have to implement that. So now our process calls this fully qualified call. And it calls the state upgrade function in a fully qualified way. So at this point, execution switches over to the new module because fully qualified calls always go to the latest loaded version of a module. That's sort of really the key here. If you do a fully qualified call, you switch over to the latest loaded version. If you're already the latest loaded version, it's just going to be like a local function call. Now, your state transformation function is going to receive the state because we would have to pass it with that function call. It's going to upgrade it and just continue the loop. Now, this time it can just do a regular local function call and it'll automatically resume in the new version of the module. All right. What's going to happen to the old module is that as soon as there are no more processes running the old module, it's going to get purged. Now, what happens is if you still have processes running on the old module of the code, on the old version of the module, and you're going to load a third version, then the oldest version is just going to get forcibly killed. So you see the mechanics of the code swap are actually really simple when you look at them in detail. Now, I just talked about this a little bit, but you really had to have the foresight to implement all of this fully qualified call and handling the upgrade message at the time when you wrote the first version of the module. So that's not really something you should use in production at all. Luckily, there's, as always, OTP to relieve us from having to think about this. And what you would usually do is not build your own kind of Gen server using like a tail recursive loop, but rather just use a Gen server and implement the code change callback in your modules. So that function is pretty simple. It basically transforms your state and returns it. Now note that whereas previously we had to just sort of resume the loop by calling our loop function, this time we just return the state. So this function receives the old version. That's just a string of the release version that we're upgrading from. Usually you don't have to care about that. If you happen to do, you can pattern match against it. Also, if it happens to be a downgrade, that old version is going to be an atom. It's going to be tuple with the atom down as its first element. But then again, I think you shouldn't really care about downgrades. And if you notice something wrong with your upgrade, you just cut a new release and roll forward. So next argument is the old state of your Gen server that you're going to have to transform. It's pretty straightforward. That extra argument, don't really care about it. It's usually an empty list. You can pass in some extra stuff if you happen to need that. So then transform your state and return it. Alternatively, if you raise an error, or if you return error, the upgrade's going to fail. And usually what that means is that your node will, so that your emulator is going to reboot using the old version of all your applications and obviously lose all its state. Now, this obviously was a sort of happy little example, and it's not going to be what you see in the real world. In the real world, your systems are going to look more like this. And what you would really want on a production machine is a controlled way of orchestrating changes. And you want to go for OTP releases. Now, at this point, when I started trying to figure out how everything about OTP releases fits together, I looked at the Erlang documentation. I read that section on releases of the Learn Your Rolling for Great Good book. And there's really just a lot of manual steps that you'd have to do. And I find that scary. Copying things around, renaming things, attaching various shells to run various commands. I found that a little scary, to be honest. But if you think about it, it's maybe somewhat understandable. I mean, Erlang evolved since like, I don't know what, 1985 or something. So Ericsson probably designed that process for themselves, for hugely complex telco systems. And they've got a lot of people who can spend all day copying files around and renaming things and running commands manually, I certainly felt a little lost and scared. Now, I don't want to scare you by not showing you step-by-step how to generate and apply a release using only the tooling that Erlang gives you, because that's really a little involved. But think about it this way. I mean, we do database migrations all the time and don't bat an eye, so why can't we just do the same with our process state if we've got a little more tooling support? So what I'm going to show you, though, are the most important concepts around OTP releases, the various files that you will find in a release, and their purposes, a little bit about the SASL application, which is sort of which brings you the sort of lowest level modules that most of the tools are using to construct and apply releases. So now these releases are really just boxes full of goodness. They pretty much give you everything you need to run and install and upgrade your application anywhere, in theory at least. Let's open one up and see for ourselves. So grab a tarball, extract it somewhere, and at the top level you will see the following folders. There's bin, ERTS, lib, and releases. Now bin, there's a convenient script in there which has just the name of your release, so it's like bin my release, and you can use that to easily start your release. You do bin my release foreground, for example. ERTS, that's basically the Erlang runtime system, the emulator. Nothing too interesting to see here, but you do want to make sure it is there. You can build releases without including the ERTS, but if you do want to use hard upgrades, you do want to make sure it's part of your release. Lib, that's where the actual sort of meat of your application lives. All your compiled source code in the form of Beam files. They are in version subdirectories inside that lib. Now there's that releases directory, and this is where it gets interesting. Now, I wonder, why is the release directory? I mean, we're looking at a release. Why is there another releases directory inside? Now, when you use hot code loading, you want to avoid falling into the trap of thinking of this release package as sort of an immutable container that you would just transfer to your server, extract, unpack, start, stop, and destroy each time you do an upgrade. It's not like that. Think of it more like a house that you would place somewhere once, and then over the course of the lifetime of your system, various files and folders are going to come and go like tenants. So what's inside that release directory? Metadata, basically. Let's look inside. There is the .rel file. That's a release resource file. Basically nothing too interesting. It just has your release name, your release version, and all the applications and the respective versions that are part of your release. The all caps releases file keeps track of which releases are installed on your target system on this node. It's the same thing, basically. So right now we're looking at sort of an initial release package. There's obviously only going to be that same metadata about that release inside that releases file. But remember, this is going to be extracted somewhere, and then it's going to stay there forever. And when you install a new release, the release handler is going to modify that releases file and tell you what's installed and which one of these is current. So then there's that other 001 directory. That's the example version I'm using here for this. Inside is a bunch of stuff like the vm.args file and the sysconfig. Basically just stuff to tell your VM how to start itself and how to start your release. That's it for the initial version of your release. Now it's time to look at a second version, which was built as an upgrade release. Let's look at it, see what's changed. So there's a relup file. That's short for release upgrade instructions file. And besides the version number, that's really the only change in structure between what I call fuller initial release and an upgrade release. There is really no notion of a upgrade only or delta release. There's only releases and releases that know how to upgrade from a given previous version of themselves. Keep that in mind, confused me. We'll look at the contents of this relup file in just a moment. First, I want to tell you about two important modules that all of the other tools depend on. They're called systools and release handler. They're part of the SASL, that's SASL, stands for, I think, System Architecture Support Libraries application, part of the OTP distribution. And you do have to list this SASL app as a dependency if you do want hot upgrades, because the release handler, that's the part that you're going to be calling when you unpack, install, or remove releases on your production system. So the SASL app needs to be part of your release. Systools, that's the sort of offline release assembly module. It does stuff like write the boot scripts, generate the relup file, and zips up your tarballs. So let's now look at the heart of the upgrade process, the appups and relups. Now, these are the actual instructions that orchestrate changes to your running system in a controlled way, which is exactly what we want. Now, we've seen that if you have a release and if you want this release to be able to upgrade from a previous version, it needs to include a relup file. I certainly was confused about the purpose of appups versus relups and how exactly they relate to each other. Basically, for every application that's part of your release, so if you have an umbrella, that's all the applications you write yourself, plus all of the applications you pull in as dependencies. And if you just write one app, that's your app and your dependencies, so it's always a lot of apps there. For each part of your app, for each app that's part of your release, you do need to have an appup file if you happen to want to upgrade that app. Now, these appup files live in the lib directories next to their respective beam files of that application, but they are not part of the release package directly, because when you assemble a release, systool is going to compile and combine all of your appup files into one single relup file. And only this single relup file is then going to be distributed with your release. So that's something to keep in mind. Let's look at an appup file here. It's basically an Erlang term. It's a triple. So first element, that's the version you're going to upgrade to. It's basically your goal for this upgrade. Now, these are the versions of the respective applications. So you have to differentiate between the versions of each of your applications, and there's another version identifier for the release, which can be completely different. Now, this appup file tells us basically the instructions to either upgrade from 001, that's the next two lines here, or alternatively, if something fails or if you just want to downgrade, to downgrade back to 001. So you read that first 001 as up from 001, and the next one, you read that as down to 001. And these are basically lists of lists. So first you can have multiple instructions. Obviously, this is just a very simple functional change. But yes, also, since they're a list of lists, you can actually have one appup file that defines the process how to upgrade from any number of previous versions. And you can put all that into one appup file by just specifying multiple down to and up from versions in here. You can apparently also use regular expressions as version numbers here, and then you match against a range of versions if you so desire. Now, here is that appup file compiled to a relup file. Now remember again, usually there are going to be multiple appup files compiled to a single relup file, but you can also obviously upgrade just one application. So it's got the same structure pretty much. On top there's your target version. Now this time we're looking at a release version, which is separate from the application versions. Again, it's got the same structure. It's a list of lists. So you get the up from version and then the down to version instructions there. You also see that point of no return. What is that? It basically just means if anything goes wrong during the upgrade process past that point of no return, the VM is going to reboot using the old version of your applications. But you really can't do many interesting things before that point of no return, so don't worry about that. Another few fun instructions that you might find there, apply. Basically, it lets you run any function that you wish as part of your upgrade process. You just specify the MFA identifier. You can use that, for example, if you want to do an hot upgrade that changes the child specs of your supervisors, or one of your supervisors. And what happens is that if you change the child specs, that's only going to apply to newly spawned children of those. And it's not going to affect the existing children, which is usually what you want. But if, in case you want to mess around with your supervision trees, you can use a function and apply it during the upgrade. Restart new emulator. Don't get your hopes up. This is not a hot upgrade. It just basically means that you can upgrade the Erlang VM as part of a release. And what happens is that it's going to start the new version of the VM, going to shut down your old version, going to start the new version of the VM using the old version of your applications, and then it's going to continue with the upgrade process and it's going to upgrade your applications. So it's really a two-step process. Sync nodes, that's interesting. If you've got a distributed Erlang setup, or Elixir setup, it's the same thing really when we're down here. If you've got a distributed setup, you can have your nodes apply the upgrades at the same time. And the mechanism whereby this happens is that you have to start the upgrade process on each of your node. And when they get to this sync nodes instructions, they're going to wait for all of the other nodes in your cluster to get there as well before continuing. All right. So we've seen how modules get hot swapped. We've looked inside a release package, inspected the relup file, seen some instructions that were generated from a bunch of appup files. Now we know why our appup files are not part of the release package. Basically, we got this thing ready for deployment, sitting around wherever we built it. Now let's look at some ways to get this thing onto your servers. The most common way probably is to use something like SSH. Copy the tar file over, unpack it, start it, and then if you get the tar flags right, that is, I just never can remember them. Later you can transfer upgrades the same way. Just this time you're going to attach a shell to your node and run the release handler, unpack release and store release. Or if you're very lucky, your tool that you use to generate the release has equipped your release with a convenient script. You just can go in and say bin my release upgrade. Now, that's fine. And it's great. You can script this to crazy heights, deploy to multiple nodes, what have you. What I'm saying is that if you have this sort of setup working for you, and if you're happy with it, then just roll with it. There's really nothing wrong with using SSH this way. Now, some of us aren't that lucky. If you happen to have messed around with releases, you might have seen this error. This is what happens when you build a release on your, for example, macOS machine and then transfer it to a Linux box and try to start it there. It just gives you this syntax error, apparently. So you really do want to build your releases on a machine that is as close to your production boxes as possible. In terms of CPU architecture, it has to be the same, so you can't do cross-compilation. In terms of OS, it really also should be almost the same. For example, this is sort of Unix and a real Unix, and that doesn't even work. So I wouldn't bother. I like containers to do that. Basically, if you're not familiar with that, they're like a VM, just a little more lightweight. They start in a few milliseconds. They're super portable, and the tooling is great around containers with Docker. So one thing you can do is on the machine where you build a release is start a container that's similar to your prod box, or doesn't even have to be that similar to your prod box actually, since you're using containers. So you start a container, build your release inside, and then configure your container so that it starts to release in the foreground when this container is run for the next time. That's basically how containers work. And then you just seal that container off, basically ship it to your prod server. Now, the tooling is really great around containers. There's a lot of tools to smoothly deploy containers anywhere. And it's going to work well again. This is something you can totally use, maybe even should use, except that you're not going to be able to enjoy hot upgrades this way. Again, if you can do without, sure, go for that. It's great. But what we really want is a way not to ship those self-contained containers, but rather be shipping releases without the containers. But we still kind of want to be able to smoothen out these OS disparities here. So one thing you can do is build your release inside a container, and then pull that out of the container and ship it then to prod and start it there. Now, you could start it inside a container in prod as well, or just on your host, depending on what you want. Now, I really like containers, so I use them everywhere, even if it's not strictly necessary. Now, I have left out one detail before. In order to build hot upgrade packages, like releases that know how to upgrade from a previous version of themselves, you really need to have the previous version that you're building the upgrade from local to where you're building the release. So basically, you want to have some kind of way of fetching old release packages to your build server or build machine, whichever you use. Now, I guess you could just SSH into prod and sort of steal the release from there, but that's not really something I'd recommend you do. It's better if you're at it, just get some place to store releases, and then you can configure your build to pull from there, build the upgrade, and push back into that store, from which then you can deploy to wherever you wish. So there you have it. Pick whichever deployment options feels right to you. Now I want to talk about some of the things that can go wrong and what you should keep in mind when you handle hot code. Let's start with messages. Now, messages in mailboxes, they may sit there for a very long time and therefore be really old. So you do want to make sure that your new code that you're shipping is still able to handle and understand the old messages that may be lying around in your mailboxes. Also, make sure that if you happen to be running tail recursive loops, that you do fully qualified calls once in a while so that you give your modules the chance to sort of jump to that new versions of the modules that you're going to be pushing. Also make sure your receive clauses have timeouts, because the release handling, so that is when you apply the release, has a default timeout of, I think, 5 seconds, which you can, of course, override, but just think about that. Now, next thing's a biggie. Anonymous functions really are the worst. You don't even have to be looking at them or executing them to totally break things. For example, if I send you an anonymous function, put it into your mailbox, and you don't even look at it, and then my module gets purged, your process is going to explode. So that's logical. So try to really refrain from sending anonymous functions around. If you do want to implement some kind of callback-style interface on your servers, just take an MFA instead. That's much more robust than sending funds around. Next thing, mixed tasks. Right now, you cannot run mixed tasks on releases yet. Now, this is probably going to change in the soonish future, because Mix is going to sort of become aware of releases, and also in development, you're probably going to run releases or something like that. Haven't really looked into it too much, but just be aware of that. And if you really do need to expose some one-off calls on your production box, it's probably just best to wrap that in a shell script and spawn an authoring shell that calls your functions. Related to the missing Mix tasks, you do want to make sure that you can run your migrations without Mix on prod. What I like to do is just have them run automatically on startup. It's easy. Now, configuration, sadly, is a bit of a mess right now. You have so many different ways of pushing or making available configuration to your dependencies, and many different dependencies just have many different ways of consuming that configuration. You just kind of do have to get familiar with more than one way of providing configuration to releases. Now, the next version of Distillery, which is the tool that you're going to want to use when you cut releases of Elixir projects, is going to ship with a feature called, configuration providers, that will hopefully make things easier in this regard. So definitely look out for that. Luckily, these days, we don't have to write our handwrite our appups anymore. Rather, tools like Distillery, they give you a very clever appup generator that compares your Beam files. That's also why you need the previous version of your release when you're building an upgrade. And that's great. Usually works pretty well, saves you a lot of time, because appups are really not that special. They're usually quite boring to write by hand. Though if you've got a very complicated upgrade situation, like if you've got many dependencies between your modules and process and nodes and what have you, then it might produce appups that may look correct but fail to sort of upgrade your system properly. And that's bad. You definitely do want to test your upgrades always, if you have the time. So what you'd have to do then is go in and manually edit the generated appups. Usually it's just a case of reordering instructions, so nothing too terrible again. But imagine if these appups are being generated on a remote machine like a CI server. There's really no easy way to mess around during release generation with your appup files. So it's really hard to do. Used to be really hard to do, because Distillery 2 is also going to ship with a way to define appup transforms. Now, that's basically just a callback module that's going to receive the generated appup instructions and is given a chance to do whatever it wishes to these instructions before returning them, and then they will be written in your appup. Now, this is a fairly low-level primitive for sort of fixing your appups, and I'm just excited what the community is going to come up with to make this easier. For example, one idea would be to use module attributes to guide that appup generation process, where you can, for example, define the load order of your modules. Versions, lastly. You do want to make sure that your versions of your applications always change between releases. Now, or else you cannot hot upgrade. What I like to use instead of these human readable version strings, if you just happen to sort of build and run your own product, is the git commit hash. That's guaranteed to be unique. You don't have to think about incrementing it by hand each time. But you do want to make sure that these version numbers are sortable in a way that a newer version of your module or your app has a greater version number. This took me a while to figure out. Just a simple way. Took me a while to figure out because my upgrades were randomly failing. Simple way to fix is just prepend the Unix timestamp of the commit, for example. So your version numbers are going to end up looking like this, which I find really beautiful. Now, that's the snippet I used to generate it. It gives you just the commit timestamp and the hash of the last commit that changed something in a given directory. So you can use this for umbrella apps where you want only to increase the version number of an app if you actually changed something in that app. Think of it like when you go to a GitHub repository, you see on the right side there's the sort of last commit hash that changed something inside a directory. Now that's a lot of boilerplate I wish we could automate. And thanks to all of you and the community, the situation around releases has gotten so much better. And today we're lucky to have some very well built solutions that you can really pretty much drop into your project and configure, and then you're usually ready to deploy your stuff. Now, if you want the absolute smoothest deployment experience, and I'm not affiliated with them in any way, check out Gig Elixir. They're a platform as a service specifically designed for Elixir apps. It's run by an ex-Googler. It's got the ease of Heroku, but respects your in-memory state and supports hot upgrades, and it comes with a CLI tool to push configuration. It's got a remote shell, and it's got really great documentation, so definitely check that out if you're interested in that. Now, on the other hand, if you do want to run on your own infrastructure, I'd suggest using Distillery as sort of the low-level primitive to assemble a release, and then combine that with either bootleg or edeliver to sort of handle all the auxiliary stuff like auto-versioning your stuff, getting the correct previous releases downloaded to your build box, compiling them maybe even on a separate build host, and deploying to all your servers. Now, bootleg is the younger project of these two. It's written in Elixir. Edeliver is sort of the first project that got this really right. Both are very solid choices. I suggest you pick one of them on top of Distillery. So, as part of my bachelor thesis that I started last year, I set out to develop yet another release tool, called it BeamUp. Now, don't get your hopes up. It's really not something that you can productively use right now. It's sort of a research project, if you will. It's definitely not production ready. There is no documentation. It doesn't even work with Mix. You'd have to compile your Elixir project with Rebar 3 for this to work right now. Yet I want to take a moment to just show you what I have in mind and what I'm working on right now. So it's based on Docker. The architecture is really similar to what I showed you before. You've got a central release store. And let's just get started. It's really easy. It's supposed to be easy. That's sort of the goal, that you newcomers to Elixir like myself can just use something to get something out of the door and just have like this lucky moment. So you do run this curl pipe shell thing on each box to get the BeamUp CLI tool. Gives you that on every machine. Then you go to your box where you want to run your store. Say BeamUp store. Now what this does is it's going to spin up an HTTP server, which is going to accept and store your releases. Next, you can go to either your laptop or your CI server. Now another thing, this tool is really designed to be completely hands-off in operation, so you should be able to run this on any CI server and don't have to worry about configuration or scripting or any parameters. So you go to your project folder, you point the BeamUp tool at your release store that you've just deployed. Just do that with an OS environment variable because they're super easy to set up on CI servers usually. You go to your project directory, say BeamUp build, and that's it. There's no arguments, no up from version, no nothing that you'd have to do. Or what's going to happen is the BeamUp tool is going to pull down the Docker container that includes Erlang for your system architecture in the correct version. Then it's going to start that container. It's going to go inside the container. It's going to pull the correct version of Elixir for your project. It's going to cache that on your host. Then it's going to try to figure out what build tool you used for your project, and it's going to compile your project. Now, before it's compiling, it's going to look at the sort of Git versions and rewrite them. And it also makes sure that you have included the SAS lab. So then compiles your project. It also pulls from the store via HTTP all of the previous releases for that project and unpacks them in the correct locations and sort of coaxes the tools to build upgrade releases from them. Then it concatenates all of the upgrade releases it just built into one single relup file, packages that into a fresh new upgrade release, and pushes that back up to the server. And it also exits cleanly, so it doesn't leave like an underscore build directory floating around on your project. So let's now look at how you'd start up a node. Go to your node, point it at the release store again. And you also want to say the name of the release that you're going to want to run, because when you've got an umbrella project, what you usually do is if you want to say like this host runs this and this app and that other host runs that other app, you cut multiple releases from your umbrella project and they each have a different name. So you tell the node which release name you're going to want to run and point it to the store. And that's basically all you have to do. It's going to do the same Docker magic, going to pull the release, unpack it, install it. It's also going to subscribe to the store. So when you use the Beamer tool to build and push another version into the store, all your nodes are going to get notified, and then they can just pull that release and apply it while running. So there you have it. Again, it's not something you can or should use in production right now, or even look at it. The code's horrible. It's really just more of a playground for me to try out ideas. It'll probably be ready this summer. I just wanted to share with you some of the ideas how Elixir deployment could work. Again, I want to point you to GigElixir or Distillery in combination with Bootleg and eDeliver. I think these projects are amazing. They do a lot, which feels right to me. Community is great. So that's it. I hope my talk has given you some ideas, maybe cleared up some confusion around the releases, and maybe even made you excited to try shipping your code while it's hot. Thank you.